biodiversity. But it doesn't have to be that way. When planned well, cities can instead reduce humanity's environmental impact as they can meet human needs more efficiently. As population, consumption, and solution hubs, cities are where change needs to happen. And it is here that the growing number of urban nature-based solutions have an important role to play. Urban nature-based solutions are exactly what they sound like. Different ways of using and including nature to heal and improve our cities. They aim to protect and restore natural ecosystems, or to create urban ecological corridors that benefit both wildlife and a city's inhabitants. One great example is found in central Seoul. Here, the construction of a city highway had buried a once vibrant river under asphalt and concrete, but the highway was removed and the river was restored to its former glory. This led to an increase in biodiversity, greater protection against natural disasters, and many other advantages for both the environment and the people of Seoul. Across the globe in Medellin, Colombia, the Green Corridors Project has created 36 green corridors between natural areas in and outside the city. These corridors encourage the movement of species, but also have a profound impact on the city itself. Exactly what nature-based solutions may look like depends on the prerequisites and challenges of each city. Around the world, we find them built into buildings and entire neighborhoods, in the planning of vegetation, agricultural, and forest areas, in the restoration and preserving of rivers, and by the sea to create living shorelines. Cities all over the world, of all shapes and sizes, are now making nature part of the solution. They have realized that the urban nature-based solutions can address multiple challenges, including climate change, biodiversity loss, natural disaster prevention like extreme weather, and food and water shortages. Join us later on when we dive into the different examples of urban nature-based solutions and how they can make our cities even better.
A very good afternoon to all of you, and a very warm welcome to all those who are joining this iCEN-57 event that is on use of nature-based solutions for combating climate change, that is jointly organized by Ministry of Earth Sciences and CSIR, Government of India. I am Shalini Dhyani. I'm senior scientist from CSIR NEERI Nagpur, and I'm your coordinator for this event. Before we go ahead with the presentation and very insightful discussions from the presenters and panelists of this event, we would like to have those who are going to share very relevant technologies about nature-based solutions for combating climate change that are developed by CSR scientists as well as the startups who are joining us in this event. Let me give you a very little brief about what iConnect is all about. iConnect is basically a series of iconic 75 Industry Connect events to showcase the achievements in various S&T areas. These events would be a fitting tribute to the pride and prestige that is associated in celebrating the 75 years of Indian independence. Now, in this regard, Science and Technology Ministry intends to draw upon the rich expertise and competence that comes from government and industry leaders who have significantly contributed to the economic growth of this country. The iConnect event is going to run from 12th of May to 12th of August. So that's a long period of 3 months and is going to have variety of programs that will enable the promotion and fostering of businesses across the country. The broader objectives of these 3-month-long events are, first of all, fostering a very strong Atmanirbhar Bharat by providing indigenous technologies that are going to be forced, that will enhance partnership with industry. This will also provide platform for interaction amongst different groups of technology experts, government leaders, academic scholars, industry captains, as well as startups. And this event will also lead to reaching out to MSMEs and startups in a very consolidated manner with a focus on funding technology development and technology transfer. Now, the idea is also for identification and establishment of network that includes government schemes, R&D setups, industries, MSMEs, startups, as well as academia together around these important focus areas. So there are diverse focus areas, and one of the important context is of climate change, as you all know. And about this topic of nature-based solutions for combating climate change, you all know that amid the climate and biodiversity crisis that not only India, that entire world is facing, nature-based solutions are increasingly being important to reduce the impacts of climate change. Nature-based solutions offer a way of addressing the climate and biodiversity crisis in a very synergistic and cost-effective manner. It is also estimated that nature-based solutions can provide about 37% of mitigation needed until 2030 to achieve the targets of Paris COP 2050. I don't need to elaborate much on NBS, as our expert speakers are going to throw more light and insights about India with reference to their technologies that they have developed. But very briefly about some of the historical development. As you know, NBS as a concept emerged and originated way back in 2012 in the Horizon 2020 program of the European Union. And the idea was to find nature-based solutions, especially with reference to heat island reduction and flash flood reduction for fast expanding urban areas in European countries. Now, over the period in last all these years, NBS has been recognized by Convention on Biodiversity, the Ramsar Convention, UNCCD, and also recently by UNFCCC. And in Glasgow COP that happened last year, has also adopted nature-based solution with the new name of nature-based climate solutions. So this is a very significant development in a very small span of time. We all know that India is also facing a lot of urban challenges, and to reduce disaster risk in urban areas, especially flash floods, reducing groundwater recharge because we need to recharge more groundwater that is slowly depleting, heat island reduction, grey water issues, another challenging area, sewage related issues that are followed by risk to sensitive ecosystem. For example, most of these sensitive areas in mountains, in Himalayas and coastal areas are also facing landslide, slope stability issues, and flood damage that needs to be reduced. And this is very relevant for the country. Now, because this event is going to be a highlight for corporates and industries, a lot of our corporate and industrial partners are also joining this event through various platforms that we have highlighted. Fast expanding urban sprawl and also urban planners of these fast expanding urban areas are also joining this program, and also disaster experts from state disaster management authorities of the country to understand and address diverse industrial issues of land degradation, industrial plantations, and most importantly, mine world restoration. So as you know, there are diverse challenges at the same time in different areas, and they all need these mega challenges all need attention of startups as well as our scientists who are working in different laboratories of the country. So to have a very fruitful discussion on these technologies, because the idea is to attract the industries to take up some of these technologies that are relevant as key takeaways of this event, especially for corporates, industries, urban planners, and disaster management authorities. This event will be the highlight and will be highlighting the context, the actions, and relevance of these technologies. Through this event, we also try to invite the industrial participants to share their questions and interest about these technologies that we can arrange further discussions later after this event as a priority. So we already have some understanding on nature-based solutions. Our speakers are already competent enough to address some of these mega challenges. And without much ado, let me first of all invite the first speaker of this event, Dr. Priya Narayanan. Very briefly about Dr. Priya, she is a program manager of urban development at WRI India. She leads the Cities for Forest initiative for WRI India. Her primary focus is to integrate effective climate action for cities and their policies. She also works on mainstreaming nature-based solutions to provide a roadmap for operationalizing in the cities. I should also share that WRI India and Priya's work has been on City Fix Labs. It's one of the very interesting, innovative concepts that involves implementers to develop nature-based solution models for Indian urban relevance that can help develop resilience building and uses the approaches of ecosystem, for example, ecosystem-based approaches for adaptation and ecosystem-based approaches for disaster risk reduction. She will share her insights about operationalizing nature-based solutions for India. So over to you, Priya.
Thank you very much, Dr. Shalini. I'm just going to share my screen. You can see it in the full screen mode, Dr. Shalini?
It is yet to be on full screen. Yeah, now it is. Go ahead.
Thank you. So good afternoon, everybody. So I think the WWF video that Dr. Shalini had shown kind of encapsulate whatever in a way I was going to speak. So operationalizing nature-based solutions in cities. So right now across India, trying to move. So we understand that the urbanization pattern is extremely messy, and the issues like urban heat, flooding, flash floods, coastal erosion in some places, and a lot of other urban development related issues are not specific to any city, but it's similar across city. And most cities, for example, there's almost 50% of built up area being added every decade. So that's a very disastrous situation because with improper and unregulated planning and with more and more grey infrastructure being added, it's very difficult to contain in a way the climate related disasters. And where are we building on? So that's the biggest question. For example, in Bangalore, 85% of floodplains of Bangalore are encroached. Most of our lakes and wetlands have been turned into sewage dumps, and rainwater really doesn't have any place to go, and that's one of the key reasons. I mean, this is there all across the globe. So and very in the South Asian countries, I think this is very prominent that flooding is a major issue, urban flooding. And the other extreme events, I mean, as we all know, 5 out of 20 Indians are highly vulnerable to all three of these extreme events, primarily floods, droughts, and cyclones. And primarily the hydromet disasters are in a way human induced, especially in the urban areas. And this is just a glimpse of how heat really is impacting millions of Indians across the world, and this is going to be the major disaster in India in the coming years. And the biggest opportunity for us, 75% of India's infrastructure is yet to be built. So there's a huge potential. I mean, there's a huge potential for twisting all our grey infrastructure into a hybrid green-blue integrated infrastructure. So that's the biggest potential for Indian cities. And I'm jumping directly into nature-based solutions, and what it encompasses, I think everybody is aware of, and what it addresses is societal challenges, climate change, poverty, resource efficiency, and use. So there's a large amount of data and evidence to show that nature-based solutions at multiple scales really have immense impact. So at the plot level, at the neighborhood level, at the city level. So they have their own ways of mitigating and adapting to climate change. So and simple infrastructure changes like having a permeable paver rather than a cemented paver really would help a lot number of cities in a way mitigating, just I wouldn't call it flooding, but just waterlogging in front of their houses or offices, etc. Just having simple rainwater harvesting percolation pits would also really enable or mitigate waterlogging. Rooftop gardens, home gardens, these are small measures that could really not only be beneficial for the environment in the long run by mitigating heat effects, but also be useful in rainwater harvesting and also in increasing the biodiversity in the city space. So these are just examples of how at the plot, neighborhood, and city level, these small interventions really can impact and help mitigate climate change and also improve basically the entire ecological space. So at the city level, constructed wetlands and urban forests, these are really big interventions that can help carbon sequestration, help completely recharging the hydrogeological cycle, and act as the constructed wetlands can even act as fishiculture areas or aquaculture areas, which could promote really the livelihood also in the areas around. So these are some examples of nature-based solutions at multiple scales. And I really don't have to reiterate the core benefits of NBS. So one is carbon sequestration, improved biodiversity, increased access to green spaces. I think through COVID, I think that's one of the things that has come up. Access to green spaces is something we all look for, mitigating heat and also mitigating flood. And how do you kind of prove that NBS is effective? There's a lot of evidence, and within India, we have one is the Smriti one, or the urban forest in Pune. So this really is an example of how community and the municipal corporation community and the local and the neighborhood of intervention has resulted in having a beautiful urban forest within the concrete jungle in a city. And there's another example from India, that is a rain garden under the Begumpet flyover. And there are multiple other examples across cities in the world. So, and on the left, you would see like how these small scale interventions really influence or, reduce the temperature, improve carbon sequestration potential. Having a treated wastewater really reduces operational cost than having a constructed wetland reduces operational cost than having a conventional wastewater removal mechanism. So these are some evidences of effectiveness of having nature-based solutions. And this is just an example of a very small example of how the urban horticulture initiative in Chennai, the rooftop gardens, is really trying to mitigate and improve building, the heat resilience in Chennai. So this is a small program which is trying to utilize the rooftops and vacant spaces, and also in a way capacitating the people to empower themselves to not only produce their own food, but also kind of use it as a means of self-employing themselves. So these are all small urban examples that is happening in India. And regardless of the amount of co-benefits that nature-based solution has, there are some very key challenges to operationalizing these urban nature-based solutions. And one is the limited number of solution providers. So I think this is the platform is really going to provide or open up space for more solution providers to come in. And the other is unavailability, inadequacy in land. So land for implementation is something that we realize that when it comes to NBS, the cities are often very dense and land becomes a very big question. The other is lack of ownership and maintenance. So this is one very important thing, because through the life cycle of a project, just implementation of a project or implementation of starting up a tree planting drive or water clearing or restoring a water body is not enough, but the operation and maintenance and ownership of that space needs to be taken. And there's limited awareness and capacity to implement and maintain urban NBS. Again, this is integrated with ownership in a way, because when you do not really own you do not really actually bother about what's happening around you. And then is involvement of multiple agencies, coordination among local agencies and also the state, city, etc. And there's a lack of standard specifications and impact measurement methods for NBS. So that is another important challenge. Like, how do you measure what you've done? Where does it impact? How much does it impact? And the other is high gestation period. So the investment for a financier is it's very delayed in a way, because anything that is urban NBS takes a long time, apart from your smaller interventions at the plot level. For example, your rooftop gardening or kitchen gardens. The investment that you do for NBS really takes a long time. And this is one of the reasons that you do not really find many people redirecting their investment in NBS, though that the potential is very high. But having said that, there are multiple things that cities across India are doing right now. So the blue-green master plan in Delhi, this is the 2041 proposed plan, has a blue-green policy specifically trying to integrate green parks, corridors, and also restoring water body. There's a similar blue-green master plan in Bhopal. There is one in Madurai. There's one in Bangalore that is focusing on water supply and sewerage. So multiple cities right now are working towards, integrating urban NBS in different ways. Some call it blue-green infrastructure, some call it urban NBS, some call it ecosystem services, but they're trying to integrate at some point, how these urban corridors or parks or water bodies are very beneficial, or will help mitigate disasters, will help mitigate urban heat, or any other kind of disaster that that city is specifically facing. So the challenges of each city is obviously very different, and each master plan does not really cater always to everything. But these kind of implementations, the urban nature-based implementation, when mandated, really could go a long way in influencing and reducing disaster in future. So I'm just jumping into what we have been doing, because this is one example of how I could say we've tried to operationalize NBS in a way. So one of the key things, just to give you an introduction of the Cities for Forest platform. So the Cities for Forest is a global initiative, and 3 cities in India have signed on to it. It's Kochi, Mumbai, and Hyderabad. In Kochi, we started on ground kind of enabling the Kochi Municipal Corporation to move towards this resilient city and shaping a resilient city chapter for Kochi. And then around 2020, we conducted Mapathon, tried to identify spaces that have the potential for tree planting, for any other kind of restoration activity. 2021, we did the implementations on ground, and by 2022, we have really enabled the city in a way, or in a way to kind of include in the city municipal budget some specific fund for taking up activities towards mitigating, adapting to climate action. So in a way to operationalize nature-based solution, I'm showing this example because to operationalize NBS, one of the key things that we understood is that it's not about these small piecemeal kind of projects that we do on ground, but how are we going to really help cities to take this on forward? And cities can only take it on forward if they use their if they earmark, or if they take climate action seriously, put it in their municipal budget, or if they are able to ask about some or if they are just able to redirect their finances in the state, from the state climate action plan, or from any other mission that the state and the national legislations provide them. So unless they have the capacity to say that we have this issue and this is a major issue that we want to take climate action and really look forward for the budget, to do any kind of implementation, water body restoration, or any kind of activities on ground, it becomes really difficult. So we strongly believe that we need to really influence the policy mandate at multiple levels, be it at the at the local body level, or at the city, or at the state level. So just in a way of that, we launched the India Forum for Nature-Based Solution. So this is what WRI launched along with NIUA and a host of other partners. We launched in the World Urban Forum in the end of June. So here we're trying to bring across India a similar language on NBS. Like I said, NBS kind of sometimes people are always talking about ecosystem-based services, adaptation, so everything. So and just trying to get this shared language of what NBS really is, redirecting investment towards NBS, because like I said, the gestation is too long. And how do you really help the investors to invest in an NBS, or invest in a solution that is useful for the cities, and influencing national, subnational policies, and integrating or mainstreaming mainstreaming NBS itself in the city planning process. So these are some things that are in progress to the India Forum for Nature-Based Solutions. And we have a bunch of people here, so the public, private, academia, NGO, and citizens. And we are primarily focusing on the private investors. At the city level, we are focusing on the municipal corporation, who are able to then identify one bankable or few bankable solutions, and they're able to move towards these investors and say that we really need to, for example, restore the canals in Kochi, or some green space in Jaipur. So we are able to influence these cities to ask investors what they need. It's not private investors, pilot implementation, which never is, most often there's no ownership from the city. So we are just trying to push to the forum and and through the Cities for Forests platform that all are city-led, community-led, and it does not go in a standalone manner. So I'll stop that and I'll end with a slide on East Kolkata wetlands that we in India, we have this amazing example of the East Kolkata wetlands, which is providing humongous opportunities and livelihood for people around while providing all the core benefits, carbon sequestration, filtering, recycling of water, acting as a sponge during floods. So this is one of the best examples I think we can take forward and understand how the municipal corporation, the local people, and the different community engaged in making this wetland thrive or vice versa. I think this is the best example for us to really take on when we want to operationalize NBS in cities. Thank you. I'll stop with that.
Thank you so much, Priya. I think that was a very relevant presentation in terms of setting the scene and putting up the right context for this event. You very well highlighted the messy urban situation because we are expanding beyond our boundaries. You also highlighted what are the work that WRI is doing, but at the same time, what are the challenges for operationalizing these NBS on ground. Very rightly put up that these NBS solutions are not very short-term solutions. So they are long-term solutions. So how to be prepared and how this mindset has to come for urban residents, policymakers, bureaucrats, urban planners to ensure that these long-term solutions are well protected, well financed, well monitored, and at the same time there is right capacity on ground so that it is well internalized by the communities and urban dwellers who are living in these urban areas. Thank you so much for this, and we have a couple of questions, but we think that we take up the questions at the end of this when all the speakers have given their presentations so that everybody gets time to answer the questions in an efficient manner. Thank you once again for this presentation, and with this I think it's time to also understand, because Priya concluded her presentation on the notes of East Kolkata wetland, a wetland that is a very good example of a man-made ecosystem that is also one of the only Ramsar sites in the country that works and is a good example of constructed wetland where nature-based solution, the UV radiation of sun and other algal combinations are used to treat sewage. And at the same time, when everybody says Kolkata is one of the cheapest cities in the country, so one of the reasons is because not many know that this East Kolkata wetland is supporting a lot of food supplies for the city. Now, over the time period, this might be also getting polluted because of increasing human and anthropogenic interferences. It is high time that we popularize these kind of stories among masses to understand the benefits and larger interest of nature-based solutions. Now, when we talk about nature-based solutions and East Kolkata wetland, we also acknowledge that grey water is a huge concern for our fast-growing urban sprawls. Wastewater coming from various sources, be it household level, industries, hospital, and so forth, so on and so forth, is a threat to our natural water bodies. It is also a threat to a lot of animals, floral, fauna, and also our human health. So what are the technologies and solutions that we have right now? Are these solutions sustainable? Are these long-term? Can there be short-term interventions as well? And also at the same time, how cost-effective they are. So these are some of the questions that come to the mind of local public and also urban planners and also a lot of corporates who want to implement these solutions. So fill this gap. And my next speaker is going to help us understand the context and share the technologies that are relevant for both large scale implementation as well as implementation as household scale. Let me introduce the next speaker of this event, Dr. Girish Pofli. He is presently working as a senior principal scientist in CSIR, National Environmental Engineering Research Institute, Nagpur. Dr. Pofli has 26 years of project management, engineering, design, and research experience within water and wastewater treatment systems. And he has provided solutions to many types of industrial wastewaters that includes textiles, tanneries, chemical, pharmaceutical, distilleries, dairies, slaughterhouse, SS rolling mills, heterogeneous. So that's a long list to his credit. And he has also developed natural treatment system for domestic sewage. Dr. Girish has developed a novel circular secondary clarifier that is called hydroplume for improved solids liquid separation in water as well as wastewater treatment. Hydrochrome is included as one of the recent technologies in CPHEEO Manual 2013. He is also expert member for Ministry of Urban Development Committee for preparation of Manual of Sewerage and Sewage Treatment. He has a lot of awards and patents to his credit. A few of them are UN Habitat Award, Dubai International Award. Currently, he is working on a very relevant Indo-European project that is on implementation of techno-economic solution for sewage and fecal sludge management under the project called Pavitar. Advocacy assessment studies upgradation and retrofitting of 7 CETPs in Ahmedabad, Gujarat, upgradation, retrofitting and implementation of 3.5 MLD STP at special economic zone in Chennai. So there are a lot of such examples of work that he has done in last few decades. And one of the recent findings on biomedical and laboratory liquid waste treatment and upgradation of large-scale slaughterhouse industries. So I'm sure the industry participants who are listening to this presentation are going to be benefiting from his presentation. And today he will be presenting and talking about grey water treatment using green wall, and that's a novel and based approach. Sir, the floor is all yours. Over to you.
Yeah, thank you, Dr. Shalini, for the warm welcome and the introduction. Am I audible and my screen is visible?
Yes, sir, it is. If you can put it on full screen.
It is. I have put it on full screen only.
Okay.
Uh,
Okay.
but are you not able to see it on full screen mode?
No, sir, I'm not able to see it in full
Oh,
screen.
it is here on my screen. It is on full screen mode.
So what if you scroll?
Yeah, it is. It is on my screen. It is on full screen mode.
So you can go ahead, I think.
Okay. Okay.
Start.
Yeah, a very good afternoon, all the participants. This is a very relevant topic given in the context of nature-based solution for combating the climate change. We had made an attempt to treat grey water using green wall, which this concept was developed actually in Europe somewhere in last decade. And for the first time, we tried to treat grey water using green wall. So there are certain plants at Pune, and then later on we tried to implement this in Niji campus for the swimming pool, the bathing water facility we have where grey water is generated, and it was implemented on pilot scale capacity of around 200 liters per day. So these are the contents of my presentation. I will be quickly going through the introduction of grey water for the benefit of my young friends, though everybody knows about grey water. Then I will be speaking about the governing regulations. My previous speaker, Dr. Priya, has also touched upon about the governing regulations. Then nature-based solution. What are actually nature-based solution? What is the importance, and to whom, which solution we should call as a nature-based solution, and how we can imbibe from our nature. How we can engineer those systems that will help to combat the pollution. Then I will be speaking on the grey water management using green wall, and then finally some conclusions and recommendations. So, as you know, that wastewater that is generated from household activities that includes toilet flushing, urinals, washings, that is utensils and clothes, and bathing, etc. So we have essentially two components which are generated from our household or domestic activity, one of which is called black water, which originates from excreta flushing or urinals, and then we have another component that comes out of the kitchen plus bath plus washing, etc. That is called grey water. If you look at the composition, around 30% of that sewage is made of black water, which is highly polluted or which has got more pollution strength, whereas 70% which comes out from other activities is grey water. So sewage is actually comprised of 30% of black water and 70% of grey water. Now, looking at the water distribution pattern in India, this is around 15% of that entire wastewater that is generated.
Sir, I'm sorry, your slides are not moving actually.
Oh,
You want me to share from here?
I think it would be good because I am on the third slide.
Yeah, so it's not
I'll
moving.
stop sharing, and then please share your screen so that.
So let me know, is this visible? I'll put it on. Is this visible?
No, it is yet not visible.
Is it visible?
No, only your screen is. We are seeing your screen. We are seeing the cursor moving now. Or shall I do one thing instead of that slides mode? Shall I, in presentation mode, shall I share my screen?
Let me just try once.
Yeah.
Otherwise, you can go ahead. Now,
Yeah, it is. It is. It is being. I mean, it is in the process. Yeah. Now it is fine. Yeah. So we were here. Could you see this this part of my slides, or I will just again
sir,
brief
it's
you?
on slide 3 now that you are speaking. Do you want to go on previous slide?
Yeah. 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 You can move on to next slide. Yeah. So I was talking about the gray water, that wastewater that is generated from household activities such as toilets, toilet flushing, urinals, washing, and bathing, etc. So basically, sewage has two components. One consists of black water, which originates from excreta flushing and urinals, and other part is from kitchen, bath, and washing. That is gray water. So around 70% is gray water and 30% is sewage. Now, if you look at the water distribution pattern in urban setup, uh, nearly 15% of sewage is made of the bathing water. 6% is this is the water distribution. 6% is required for drinking and cooking purpose. So gardening requires around 17%, and for toilet flushing, it requires around 30%. So, if you look at the percentage of water required for flushing and gardening, it contributes nearly 50%. So, treatment of grey water and its recycle and reuse for flushing and gardening can cater nearly 50% of the total water supply. This fact itself justifies the need for treatment and recycle and reuse of grey water so that it can conserve huge amount of fresh water. Presently, it is actually it's very alarming sign that we are using fresh water for flushing our toilets. So, in order to prevent or conserve the freshwater resources, we need to treat the grey water, which nearly contributes 70% of the total sewage. Yeah, next slide, please. Yeah, this is very important aspect of governing regulations, because we need to know to what level we require treatment to sewage or grey water, uh, because that decides the treatment the method or treatment selection. So for sewage, we do have standards, discharge standards, which are now referred to as NGT norms, because these norms have yet to be notified by MOEF CPCB. So, for example, pH, we have these norms: BOD less than 10, suspended solids less than 20 or 10, 20, COD 50, nitrogen total 10, total phosphate for discharge into ponds 1, fecal coliform desirable 100 and 230. So, these are the norms which are available for sewage. Next slide, please. But as far as grey water is concerned, there are no specific standards for treatment and recycle or reuse for grey water prescribed as yet in India. Uh, There is one report or the manual prepared by CSR NIDI along with UNICEF in 2007, in which there were suggested guidelines were prescribed for grey water quality, in which you can see that, but that is related to only bacterial logical quality, and one only reference of BOD, that is also from CPCB, that is class A water. So as such, we do not have any standard or treatment method which will say that to this level we should treat gray water, and then that will be useful or fit for the recycle and reuse. So whatever gray water treatment is being done presently, we are using only the sewage standards to that level we are treating. So this is very important aspect if you want to manage gray water and reuse it for any non-potable or for that matter any potable purpose. So this is one important aspect in gray water treatment and management. Next slide, please. Yeah, a brief of about nature-based solutions. The environmental cleansing mechanism that ensures reduction of pollution levels by means of physical, chemical, and biological transformation without any human intervention can be referred to as a nature-based solution. Then some of the examples include inner solid removal through filtration. This is a physical process. Metal removal through soil sorption is a chemical process. Nutrient uptake by plants, that is phytoremediation. And organic matter removal by microorganisms is a biological process. So NPS is basically combination of all these processes which we imitate from nature. Another aspect is that natural treatment system might be slow, but they are safe. Taking place, and then do some engineering on that, and then that's how we can save a lot of energy or whatever recurring expenditure are expected. Next, please. Yeah, there are some examples of natural treatment systems. Dr. Priya also showed about the wetlands. The prominent natural systems often encountered in wastewater treatment are wetlands, soil sorption, soil aquifer treatment, and anaerobic systems. These are some of the examples, pictures of all natural processes taking in the nature. That includes natural wetland. This is soil aquifer treatment. This is soil sorption. This is a chemical process in which adsorption process is basically used it takes place and takes uptakes the metal part in soil or in water. And this is a biological system which also takes place in pond system. So these are some of the examples of nature-based solutions. Next, please. Yeah. Now we come to one of the nature-based solution that was implemented here, that is called green wall or bio wall. It has got a few components. It consists of a bio wall frame made of MS mild steel frame, and then it uses some certain area. It has got dimension of around 11.5 centimeter by 1.5 centimeter width, and height is 12 centimeter. And there are some plastic or recycled polypropylene uh, pots are used to fix these pots on that wall mounted frame. So the capacity of each pot is around 1 liter. Another component which is used in prominently used in that particular pot is a filler media, which is called as lightweight expanded clay aggregate or LECA. Uh, it is basically light in weight, and it has the gradation start from 0 to 4 mm. It has got good water absorption capacity. It is thermal insulated, and most often it provides good filtration. And there are plant species which are used, which are stability also very good, and also have capacity to uptake the nutrients. Well, I'm not a botanist, so I don't have much knowledge on this. So probably Dr. Shalini is the right person to answer this. Another filter media that is used to fill that pot is coco peat. It has got high water holding capacity. Of course, some due to porosity, some air is also filled, and it is 100% organic and eco-friendly. So these basically these two combinations of cocopeat and leca, they offer a physical process of separation of solids. It also helps water to retain in that filter media and also allows some microbial growth, and thereby some organic matter is removed. So physical process takes place, biological process takes place, and the plant uptakes the nutrients. So this is what the function of green or biowall is done. Next slide, please. Yeah, this is the a small scale plant for which shows hydraulic flow and schematic diagram. There you can see wastewater. The gray water is collected from the bathing area, and then it is pumped to an overhead tank, and then it is distributed to three different modules of the wall frame on which the pots are attached. And after treatment, the treated gray water is collected, and then the treated gray water is collected into this collection tank. This shows the schematic. We have sump for gray water. We have a degreasing tank, then the collection tank, and then the green wall components that includes leca in first and leca plus coco peat plants, and the final treated option, treated effluent or collection tank. So this is the arrangement that was made for treating grey water that was generated from the bathing area in swimming pool at Miri. Next slide, please. Yeah, this shows the experimental setup and wastewater, grey water characteristics. If you look at the characteristics of grey water, they are, quite dilute as compared to sewage. It has BOD 48 to 70, COD 64 to 92. Normally, if it is sewage, it varies about 150. If it is for sewage, COD goes about 250 to 300. Oil and grease, it has got good amount of oil and grease, and other components like phosphate and total delta nitrogen TKN less than 30. So this is the wastewater characteristics, and these are some of the wastewater characteristics from grey water characteristics from some other studies. So we consider these design values, and based on that, we design three different modules using three different plant species, and gray water was treated using two different filter media, that is leca and in combination with coco peat. Here, the one thing to notice is that oil and grease is to the level of 20 to 30 milligram per liter, which is quite high because this gray water comes from the bathing area. So people use a lot of hair oil or shampoos, and so that contains a lot of oil and grease. So it was thought of treating the first the removing the oil and grease component, and then further treat it through the green wall these plants. Next slide, please. Yeah. Uh, since we had some oil and grease in the gray water, we designed a baffle wall based oil and grease tank in which raw water enters here from this area. This is the plan, and this is the section, and water flows from the bottom and then goes to next chamber, and then it is finally collected from this. So at the top, all the oil and grease is removed, and then thereby it reduces the oil and grease content, and subsequently BOD and COD of the grey water also. So BOD of 70 was reduced to 48, COD from 90 to 68, and oil and grease was also substantially removed from 30 to 16. So it resulted around 40 to 47% of oil and grease into the at the outlet of degreasing tank. So the idea is we must analyze the characteristics of grey water, because grey water characteristics are they vary hugely in terms of characteristics, because they originate from different sources. So we don't know from which sources we are collecting. If it is from all the sources, then the gray water characteristics will be different. But here in this case, it was only from the bath area of that swimming pool. That's why we have prominent oil and grease in this section. Next slide, please. Then, well, I have a lot of data on this, but I would like to cut short just to show you that treatment with light expanded clay aggregate, that is LECA, we had good performance, satisfactory performance in terms of COD, TKN, and total phosphate removal. But BOD removal was not up to the mark. But again, up to the mark means we had no standard, so we compared with the NGT norms, and therefore, in that aspect, BOD was not reduced to less than 10 milligram per liter. The reason was we had maximum retention time was of around 12 hours, that lake soil. So to increase the water retention and subsequent treatment efficiency, we used coco peat in equal proportion that was mixed with leca. Next slide, please. So after using combination of leca soil and coco peat in equal proportion, then we got very good retention capacity, water retention capacity, and then we could run the system at different hydraulic loading rates, or you can say hydraulic retention time. You can see that it started from 18, 16, 14, and 12 hours. We first loaded the system with minimum flow that resulted in maximum HRT, and subsequently we went up to 12 hours retention time. And then we observed that combination of LECA and coco peat provides higher water retaining and hence provides higher hydraulic retention time, which enhances the performance of green wall. So accordingly, total suspended solids and BOD concentrations at all these loading rates were well below the standard which are prescribed by NGT for sewage. And accordingly, the effluent TK and COD concentration at 18 hours were also well below the prescribed limits. At 12 hours, COD and TK reductions were quite low, which were meeting the compliance norms of the NGT. So this indicated that gray water treatment is possible using green wall, and which offers around 14 to 16 hours retention time. We can substantially treat it, and that will give us that quality of water which can be reusable in garden, or at least for toilet flushing, which will not have any adverse effect. Uh, we have also monitored the fecal coliforms, which were also reduced to less than the permissible limit of 230 and 100. Next slide, please. So, advantages of nature-based solutions, which are quite obvious. They are highly techno-economical and environmentally sustainable, requires low capital and O&M costs. They do not require skilled manpower. All that you have to do is to just provide uh, these plant-based media, and you have to just set the flow rate, and automatically water gets filtered. Significant treatment efficiency with the removal of primary and secondary pollutants. The treated effluent can be used for non-potable purpose like gardening, floor washing, flushing, and green belt development. And in particular, green wall systems, if you have a lot of green wall systems, they can significantly reduce the fresh water demand, uh, reduction in carbon footprint area. They are also help in temperature control, and of course, they are aesthetically and socially acceptable and economically feasible. This particular system was set up only at around 20,000 rupees for 200 liter per day capacity. So you can see that you can save a lot of fresh water, which is otherwise used, and that cost can be recovered if you save that fresh water cost, because fresh water costs you around 20 rupees per liter per meter cube in urban setups. Next, please. So some conclusions and recommendations. Grey water treatment and management using green wall gives us an opportunity to conserve the environmental resources and serve the society at large. If small, like government bodies, public sector, private industries, and municipalities can target to conserve the fresh water using grey water treatment and reuse of non-potable purpose. Another important aspect or recommendation would be it is essential to formulate treatment and discharge standards for grey water with recourse to recycle and reuse, because presently we do not have any target value. So to what level we should treat it so that it will be amenable for recycle and reuse. I did not include some of the conventional technologies which are also prominent in grey water treatment, since the topic is on. But there are certain technologies like simple filtration or sedimentation using some chemical coagulation and flocculation. But those method actually create some sort of another problem like the sludge handling. So natural system or the green wall concept has an edge over conventional systems. That's also one of the important advantage of nature-based solution. Yeah. Next one. I think I have come to the end. Yeah. Thank you very much for the patience hearing. I have actually covered quickly because of the time limitation. If there are any queries, I would be very pleased to answer those questions. Thank you very much.
Thank you, sir, for this presentation. I think green walls are one of the things that you see right now everywhere. You see them on the airports, you see them on big hotels, and now even metro pillars and flyover pillars are also having these green walls. And there is a lot of attraction also. Everybody wants to have these green walls in their campuses, schools, everywhere. Good
Right.
thing about this presentation is that you have touched upon how this system can be actually engineered and how it can help us to solve some of the grey water issues of urban areas, and how can it can help us with, having water that can be used and repurposed in some other uses.
Right.
So good thing was that you talked about using the frame that was used from recycled plastic, and it was a very interesting presentation with a combination of engineering, chemistry, and biology. So that also means that NBS is no more property of an ecologist or a biologist. It has to
Yeah.
be a transdisciplinary, multidisciplinary approach where a chemist, a engineer, even economist, social
Yes.
scientist, everybody can join and contribute their concerns. And something is very relevant because my forthcoming speakers of this session are going to highlight these some of the important areas of also how they grow plants and how they can use in urban areas. So I think this can be very relevant for them if they want to take up, and also for the corporates and industrial partners, urban planners who are part of this program. Uh, I have some questions a bit, but you have, I think, addressed the sustainability of this issue, this technology, and how it is so cost effective, and how it can also run for a longer time with a small investment. Uh, so I will reserve my questions for the end, so that every speaker gets enough ample time to share their technologies. So thank you once again, sir, and
My
now I move to the next speaker, but before I move to the next speaker and his interesting technology sharing and presentation, I think one thing has been very clear in last Glasgow COP that was in 2021, and where India actually promised a lot about net zero, fast decarbonizing. That also means that a lot of our dependency that of power that right now comes from coal, and especially unabated coal, is going to significantly reduce in coming decades. I should say in coming at least 1 decade or two, we will be having a significant dependency on renewables. While India is right now having about 60 plus percentage of its power coming from coal, and this is not only leading to a lot of land degradation, it is also resulting on massive impact and generation of fly ash every day. And those who are working with industry, especially thermal power industries, they know that such a problem this fly ash is for them, because they have to completely utilize it, ensuring that it doesn't goes out, it is not seeping in the agriculture areas in the natural ecosystem. So to solve these issues, what kind of technologies we have? And while this is a challenge, this may also have the potential to solve a lot of our urban issues, especially if we can develop certain materials that can help us with enhanced groundwater recharge. That is an urban issue We know concretization has resulted in reduced groundwater recharge. And also, is there any potential to see that these advanced materials can help also in sequestration? Because these kind of materials are one way or other coming from natural resources. And at the same time, because nature-based solution has in its core addressing and solving societal challenge. And this is the biggest societal challenge. Every now and then we hear that in one of the thermal power plants, these fly ash is spilling over, and then NGT comes in picture. So to address all these questions, I have my next guest for this event, and I would like to invite Dr. Manish Mudgal, who is Senior Principal Scientist and Head of Center for Advanced Radiation Shielding and Geopolymeric Materials in CSR Advanced Materials and Process Research Institute, that is AMPRI, in Bhopal. He has extensively worked on advanced radiation shielding materials for strategic sector that utilizes industrial waste, especially red mud and also fly ash. He has developed synthetic radiation shielding aggregates that are utilizing red mud. He has also developed radiation shielding concrete utilizing developed synthetic radiation shielding aggregates. He has also worked on advanced cement-free fly ash-based geopolymer, and that has helped in developing concrete for road and infrastructure applications. As you can see, such a wide and diversified, interesting experience that he brings to this panel and discussion. He has several publications, projects, and awards to his credit, and especially he has transferred a lot of technologies to industry, especially related to know-how for cement-free fly ash-based green concrete development. And he has also developed and demonstrated 6 important technologies that he has developed at CSIR AMPRI Bhopal and AIMS Bhopal, that include cement-free reinforced concrete structure, cement-free concrete road, LSA cement-free concrete paver block pathway, instant geopolymer concrete for pothole repair of road, ferrogeopolymer panel structure, and also advanced solid form geopolymer concrete road at AIMS Bhopal. Such an interesting contribution to the country and science. He is also been one who created the major national level facility for Center for Advanced Radiation Shielding and Geopolymeric Materials at AMPRI Bhopal. So, sir, we look forward to have your interesting technologies and the insights about fly ash and other ways that are coming to the environment from industries. Over to you, sir.
Thank you, Dr. Shalini. First of all, I am thankful to Director Niri and especially CSIR for conducting this iConnect program. And I am thankful to my director who has given me permission to share this technology with all dignitaries present in iConnect program. So thank you so much. I am just sharing my presentation. Is it visible?
Yes, it is full screen, sir. You can go ahead.
Yeah. I would like to share once again that I was in Navy from 1993 to 1995. So I worked in around 2 years at Niri Nagpur in the Environmental Impact Assessment Division. So I have that particular work this work culture of Niri Nagpur. So friends, I will start my presentation on development of advanced cement-free fly ash-based geopolymer concrete and red mud-based radiation shielding concrete also we have developed. But firstly, I will go for advanced cement-free fly ash-based geopolymer concrete. Need of R&D and alternative binder. The concrete is the largest man-made material utilized by mankind. Concrete contains 20 to 30% binding material and 50 to 60% coarse aggregate and 20 to 30% medium and fine aggregate. Conventionally, all of us are knowing that the concrete is made by ordinary Portland cement as binder. And because 1 ton of cement produces around 1 ton of carbon dioxide, so this is not a eco-friendly process. It is an energy-intensive process, and to save the natural resources and environment and ensuring the bulk utilization of industrial waste, there is an urgent need to develop any alternative material, that is fly ash-based cement-free geopolymer concrete, to replace conventional cement concrete for broad application spectrum. So background is that why we need alternative cementitious material. I told you that cement is highly energy intensive. Around 1450 degrees centigrade temperature is required to produce clinker, and 1 ton of cement produces around 1 ton of carbon dioxide, and cement production results in 8% of world carbon dioxide. So you can see it's high energy intensive, as well as it is not an eco-friendly process. So we have thought of using fly ash as an alternative material for development of this technology. And what is fly ash? The fly ash is a byproduct of finally divided residues resulting from combustion of pulverized coal in thermal power plants. And in India, we are generating 226 million tons of fly ash per annum. Friends, we are producing 230 million tons of cement per annum in India. So the amount of cement production is equivalent to amount of fly ash generation in India. It is an aluminosilicate material with a fine particle size distribution, combination of glassy and crystalline phases, and it has a pozzolanic characteristics. The data we got from Central Electricity Authority, New Delhi, 2020 data is that we are generating 226 million tons of fly ash from 197 thermal power plants in India. Its utilization means, if you see the forecasting of that, so in 2030-31, we will produce around 600 million tons of fly ash in India. So you can imagine the quantity of fly ash will be generated in India. The utilization is very minimal, and you can say utilization of fly ash in different sector I have shown you. The basically environmental impact of fly ash generation is on air environment as well as water environment, on land environment, and just like if we throw the fly ash on ground, it will degrade the environment in all aspects. It is only change of mindset. Since last 200 years, we are using cement concrete. हम जो घर में सोते हैं, हम घर में रहते हैं, that is made of cement. Dear friends, agar I am just telling you, if it is the confidence that we are sleeping under the rooftop made of concrete. So our mindset is of that level that we are confident that this will not fall down. So इतना confidence होने के बाद we are sleeping under that rooftop. Now there is a need of change in mindset that this waste can be utilized to make wealth out of it. And how we can do it? We can do it by converting into geopolymeric binder. We have worked in since last 15 years. I am working in this particular field. I have guided around 25 MTech students, 5 PhD students on this particular geopolymeric concrete work, R&D development, and carried out n number of projects on this particular development of technology. I am working on bulk utilization of waste. That's why we have collected around 21 tons of fly ash from nearby thermal power plants at Sarni, Government of MP thermal power plant. We have characterized this fly ash and we got that it is a silico-aluminous material. Silica content is 58.63%, alumina 27.7%, and iron oxide is 6.5%. So if we go through the IS code, that is Indian standard for IS 3812 part 1 for pulverized fuel ash specification, where this particular ash is being added in the with the cement to make pozzolanic Portland cement. And as per this IS code, if silica, alumina, and iron oxide is in combination, if we add these three constituents, if it is more than 70%, it is class F fly ash. So this fly ash, what we have collected from this thermal power plant is class F fly ash. We have thoroughly characterized this fly ash with XRD, particle size distribution, FTIR, scanning electron microscopy, uh, and even with transmission electron microscopy. And it contains glassy particles and crystalline particles in it, basically quartz and this amorphous silica in it. And now I'll come to this is a base material we have used for geopolymer making. So what is geopolymer? It is a green material. It is 80% less carbon dioxide generating material, low consumption of energy and water, better durability, simple process, and wide range of application. That's why it qualifies as green material. Professor David Ovid from France, he is the inventor of this geopolymer. He has coined in 1978, David Ovid proposed that alkaline solution could be used to react silicon or aluminum in a source material of geological origin or in any byproduct material such as fly ash, rice husk, clay, or to produce binding material. So he told that if any silico-aluminous material, when reacted with alkaline solution, then the binding material will be a viscous material. It is a viscous binder, and he has coined the name as geopolymer. It is not a polymeric material. It is not an organic polymer. It is an inorganic polymer. You can say it behaves like a polymer material. So geopolymerization reaction is a chemical process that rapidly transform partially or totally amorphous aluminosilicate source into three-dimensional polymeric chain and ring structure having SiO-LO bond. The aluminate silicate material can be fly ash, can be slag, metakaolin, silica fume, rice husk ash. Any one of it can be utilized. Alkaline activator may be sodium hydroxide, potassium hydroxide, sodium silicate, or potassium silicate. And if we see the mechanism, it is having solid dissociation, polymerization, gelation, setting and hardening, solid state transformation and of aluminosilicate gel. Basic form of geopolymers, polysilicate, polysilate, siloxo, polysilate, disiloxo, different stages are there. And two different scientists, David Ovid and Barbosa, has given different models. And the basically raw material required for this particular geopolymeric concrete is fly ash, class F fly ash, as I told you, sodium hydroxide and sodium silicate, and conventional fine and coarse aggregate, what we are using in concrete. Friends, if we compare the Portland cement and geopolymer binder, Portland cement needs 1450 degrees centigrade for its making clinker, while this particular process only we need 35 to 80 degrees centigrade temperature. So that is you can say cement production is an industrial production. This particular concrete can be made at your doorstep. Then here in Portland cement, after making Portland cement, when we add water, there is a CHS gel to make it harden state and to get the strength. Whereas in this particular system, there is a formation of SiO-LO bond 3D network, and only with the drying mechanism you can get the strength. So this particular geopolymeric concrete is not requiring any water curing. And if you calculate we have calculated the carbon dioxide emission from this particular geopolymeric binder, so it is 83% less carbon dioxide generating material means only 0.17 tons of carbon dioxide per ton of geopolymeric binder. If we go for comparison of this engineering properties, so engineering properties, it is this particular concrete is segregation free concrete. It is not requiring water curing. And another advantage of this concrete, it is high temperature resistant concrete. It is resistant to sulfate and acid, low shrinkage, low thermal expansion, low creep, and excellent durability. These are all what I have showed you till now. This is all the R&D part of it and literature review of that. But really what, after developing this particular binder, we have, my colleague scientists asked me to do some demonstration in the campus. So we have thought in 2014, we have demonstrated a 3.75 meter by 34 meter stretch in our campus. And these are the photographs of 2014. And we have demonstrated one patch of road in our campus. And you can see by physical seeing, you cannot differentiate between this concrete and cement concrete. This color is same because fly ash color is similar to cement. And this with the conventional equipments, we could do this demonstration. And after this is the road patch we have demonstrated in 2014, and the engineering properties is like that. Its strength was 35 MPa, flexural strength 4 MPa. At that moment of time, in 2014, the slump of this particular concrete was very low, because we have made this concrete with liquid alkaline activators. And this is the problem, this is limitation of this particular process, that its workability is very low. And it requires 35 to 40 degrees centigrade and temperature, and bulk handling of alkaline activator solution is needed. These are the constraints or limitation of this process. In this particular demonstration, I have used 8 tons of fly ash in this particular demonstration. Friends, this road is still in my campus being utilized, misused by my colleagues in AMPRI Bhopal. And day by day, the findings is that day by day, after every year, we used to go for a core cutting of this particular sample, and strength is increasing day by day. Now the strength of this particular road stretch is M39, means 39 megapascal. Then we have improved this process, fine-tuned the technology, and then with the improved process and with the solid form alkaline activator, we have demonstrated this road stretch in All India Institute of Medical Sciences, Bhopal. This is the RM800 plant we have used. This is the photographs of demonstration of cement-free concrete road at AIIMS Bhopal in 2017. Now you can see these are the with the conventional road construction equipment, with the help of Central Public Works Department, we have demonstrated this particular road stretch at AIIMS Bhopal. And you can see within 2 days of time, we have demonstrated around 30-meter patch in this AIIMS Bhopal, and still the strength was 35 MPa, fractional strength 4.2 MPa. At this particular time, we could develop a super plasticizer for this particular concrete, and the minimum, the slump we could achieve 120 to 130 mm slump, means workable concrete we could make at this stage of development. And after 7 days of drying, this road was ready for use. After post-performance studies was carried out for 4 years, and these are the photographs in December 2021, the fly ash-based concrete road, and parallelly we have constructed this concrete with cement concrete. And the fly ash-based geopolymer concrete, the crack pattern is very minimal, shrinkage is low, thermal expansion is low. Because of this, we could make the very durable road for all weather condition. The major raw material utilized with this particular concrete is fly ash from electrostatic precipitator of coal waste thermal power plant, conforming to IS 3812. Alkaline activators, conventional coarse and fine aggregate. Major plant equipment machinery required is concrete mixer, vibrator, conventional construction tool. The limitation already I have told, it's a low workable concrete, minimum required temperature 35 to 40 degrees centigrade, and it needs 10 moment power for handling of alkaline activators. So with the development, the salient technical features are there, that it is bulk utilization of industrial waste, that is fly ash, class F fly ash, eco-friendly process, around 80% less carbon dioxide emission, obviates the need of water curing, energy efficient process, only at 35 to 40 degrees centigrade you can make this concrete, can be made by using conventional machinery. Increased productivity and strength will achieve about in 7 days only, as compared to 28 days required for conventional cement concrete. Cement concrete needs 28 days for development of around 90% strength, whereas in this particular system we can develop in 7 days only. Only requirement is that there should be 35 to 40 degrees centigrade ambient temperature. Bulk production will provide saving in project cost and duration, and initiative under Atmanirbhar Bharat and Swachh Bharat program of Government of India. I am glad to share you that we got 3 US patent granted on this particular technology, and one patent already filed in 2021. There was a media coverage of this particular technology from this Dainik Bhaskar on 15th May 2019, that fly ash se bani sadak, cement se zyada majboot. Already they are utilizing it, and offshoot of it we have developed high strength paving block with 50 mm thickness with this particular concrete. We have also developed a reinforced green concrete structure in our, and it is there in our premises. These are the photographs of that particular structure. And I would like to share you that this is the first structure of the world. It was shared by Professor David in 2013, that CSIR EMPRI is the first to make reinforced green concrete geopolymer concrete cast in situ structure of the world. So although it is very small, but it is the first structure of the world. So it is there. We are studying the durability of this concrete on this particular structure. And why I am telling you it is a durable concrete, it is proven, it is in literature, that the Egypt pyramids were made by similar type of geopolymeric material. So it is proven, it is in literature, that geopolymer is having a more durability than cement concrete system. Friends, with the continual development and with all the help of Ministry of Environment, Forest, Department of Science and Technology, DST, and Board of Research in Nuclear Sciences, I could, with the mentorship of my director, Dr. Avnish Kumar Srivastav, and my senior colleague, Engineer R.K. Chauhan, we have established one Center for Advanced Radiation Shielding and Geopolymeric Materials. This center was inaugurated by the then Minister of Science and Technology, Dr. Harshvardhan sir, Honorable Minister of Science and Technology in 2021. 13th March 2021, we have got inaugurated this particular center. And this center we have established under DST CSIR project of 5.59 crore, sanctioned from DST and CSIR. And in this particular center, we have established the facility for upscaling of technology in the area of radiation shielding and geopolymeric materials. This center objective is upscaling of technology in the area of radiation shielding and geopolymer material utilizing industrial waste for extending technological support to Indian industries. It is working on strategic sector, nuclear installation, defense. For we are developing concrete for bunkers, missile launching pad, airfield runway, nuclear radiation shielding concrete for nuclear power plants, for radiation shielding concrete for X-ray diagnostic and CT scanner rooms, whereas for rigid pavement roads and environmental conservation is a bulk industrial waste utilization and development of eco-friendly material. Friends, I would like to share with you the technology developed by CSIR EMPRI and in the mentorship of my director, Dr. Avnish Kumar Srivastav. We have approached Ministry of Road Transport and Highway, and last month we had a meeting with Honorable Minister of Road Transport Gadkariji, and the proposal was submitted to Ministry of Road Transport MORTH, and in principally that particular proposal was approved for demonstration of this particular concrete on national highway. So this is the finding, and future plans of this particular my center is making solid powder geopolymeric binder. We are developing ready mix concrete, ready mix geopolymeric concrete for structural application. We are developing blast resistant concrete for bunkers, whereas we have submitted one proposal to ISRO for thermal resistant concrete for missile launching pad, pre-stressed concrete railway sleepers, and these are our target sectors: NHAI, DRDO, Railway, NTPC, ISRO, Border Road Organization, and MOEF. So this is the center what I was telling about, Center for Advanced Radiation Shielding and Geopolymeric Materials. So I have established this center under this CSR DST project, and now I am heading this center at CSR EMPRI Bhopal. Thank you for giving me opportunity to share my technology. Thank you so much.
Thank you, sir. I think this is one of the very relevant presentation because it highlights the industrial waste. That's a big menace, and at the same time, headache of a lot of industries. You have very also highlighted for whom these technologies are relevant. You have highlighted NTPC, and I'm sure because this event is shared with NTPC audience also, so I'm sure they will be participating and seeing the live telecast of this. One thing was very important that I would like to really reinforce from your presentation, because you talked about all weather conditions, how these roads and geopolymeric concrete binders are very much relevant for making all weather road. While we all know that Government of India is making strategic connections in border areas by having all weather roads, I think this is where your technology is going to play a very big role. And when NHI is already going to collaborate and participate with you, I'm sure we will see a lot of these developments in coming year. I have a couple of questions that I've received from the audience. I'll be keeping them for the end of this session so that we can have a little more insights about cost effectivity and other heat stress concerns, because we have already highlighted the temperature conditions and how they are also able to reduce carbon emission. So while a lot of these discussions on nature-based solutions globally target urban areas and also natural areas, how we can reduce disaster risk, we never talk about how to use this waste to solve societal challenges in a very sustainable manner. So thank you, sir, for bringing that very insightful angle to this discussion and giving us some technologies that we can later discuss and think about. Thank you once again. And now I move to the next presenter of this session. And before I move ahead, I would like to go through one of the videos that will help you understand what I'm talking about right now.
All of us in the cities are eating vegetables which are originating from areas where industrial effluent water is being used to grow the vegetables. So what we are basically eating is a little bit of cancer every day. Most of our cities are now guzzling electricity. If you add the corporate structures, the corporate offices, they're like giants which are drinking electricity every day. So while we are trying to keep our houses cool, we are burning the planet. We felt that if we could develop a natural green cover on the rooftop, we could save the exposed rooftops from the sun. And while we were working on that problem, we realized that a solution for climate change or a solution for saving the rooftops could also save the health of the people who are living in that building. So we put all these problems and challenges together, and finally we created this rooftop organic farming model.
One of the things that attracted me to this is that it uses a soilless medium and it uses very less water. It has drip irrigation, and in one bucket full of that's about 17 liters of water, we are able to water about 45 square feet of or 60 square feet of soil. I think it's a very practical decision now to take to protect our resources, and more than that, to protect our livelihoods and to protect our businesses, and to see them reach the next generation or the generation beyond.
कितनी खुशी होती है कि जिस तरह आप एक बच्चे को अपने सामने ग्रो करते देखते हैं, उसी तरह आप देख रहे हैं कि आपका जो फार्म है, एक छोटा सा फार्म है आपके घर में, वो आपके सामने ग्रो कर रहा है और वो अब धीरे-धीरे उसमें वेजिटेबल्स आ रही हैं.
Now the big question is, how do we make money in this venture? The first thing, we sell this beautiful rooftop organic farming unit, which can be installed on the terrace of any customer, and that person can grow his fresh organic vegetables every day on the terrace. The second thing is, we make our own organic inputs. 75% of the organic inputs that we use in this rooftop organic farming unit have been created indigenously by us at our farm. Third thing, which is very, very important, we offer weekly maintenance support to our customers. And fourth, we also offer an organic kitchen gardening program, which any citizen of the city can enroll himself into. My dream is that every single rooftop that you see here would be a huge, lush green organic farm.
So you might have some idea of what we are going to discuss now. You know that we are losing a significant amount of urban green spaces across the country, not only in our country, but everywhere where you see urbanization is exponential and rampant. So this is not only compromising food security, especially for the people who are migrating to these cities without understanding what livelihood opportunities are waiting for them. And as Dr. Priya in the very starting of this event already highlighted, that urban residents are also having a kind of disconnect with nature. So to enhance nature connectedness, some kind of psychological benefits that we are always searching for in urban areas, and of course, improving the microenvironment condition, especially reducing heat islands, ensuring that everybody gets that kind of right, clean food that our next speaker was talking about in this video. So for this next presentation, let me please welcome Mr. Pratik Tiwari, who is founder and CEO of the Living Greens. He started this concept and this company, the Living Greens, as India's first rooftop organic farming company in 2013. And this was started with a mission to convert rooftops, not lush green organic farms. Today, the Living Green is one of the India's largest growing rooftop organic farming company. It has more than 1,500 customers across 25 different cities of the country. It is also the largest rooftop farming company registered with the government of Bihar for the rooftop gardening subsidy scheme of Bihar Horticulture Department. Let's have his insight and understand more about how to convert rooftop into organic farms to create food sustainable and livable cities using nature-based solutions. Over to you, Pratik ji.
Namaskar, ma'am. Thank you so much for giving us this opportunity to share our work. Another thank you for showing that video that makes my work a lot more simple. My name is Pratik Tiwari, and I'm the founder and CEO of Living Breeds. And just like this little girl that you're seeing, just like this little girl, I too have been telling the world for the past 10 years that the time has come that we have to convert rooftops into organic farms. Next slide, please. Next slide, ma'am.
Yeah.
Can I share my screen?
No, it's working.
Okay. So why are we talking about rooftops? The answer is very, very clear. Today, rooftops form the largest unutilized space in a city. You look at any city on this planet, inside any city, the largest unutilized space are the rooftops. And not only are they they are the largest unutilized space, but there is another problem. This entire unutilized space is directly impacting the urban heat island effect. These rooftops are exposed, they are barren, they receive a lot of sun, they heat up the building. So because of heating up of the building, not only is the overall heat signature of the city rising, but the energy requirement of the city to cool its building is also rising. So today we are reaching a point when living without air conditioners is next to impossible. And even before we have reached that point, the next bad news has already arrived. The next bad news is that air conditions will fail to work when the day temperatures go beyond 50 degrees centigrade. So the time has come when we have to think about passive cooling of the city. Next slide, please. So what are we talking about? What we are saying is, and this is a dream that we are sharing with all of you, those barren, exposed rooftops can be converted into organic farms. Think of it in this way. The building in which you are sitting right now, 50 years ago, 60 years ago, maybe 100 years ago, there was a green farm there. That farm was removed and the concrete structure was created. Now, what we are saying is, in order to reverse that damage, why can't we bring that farm back on top of that concrete structure? And that is why we are talking about rooftop organic farming. And it has other advantages. When you are converting your rooftop into an organic farm, you are cooling the building. The plants are actively sequestering carbon dioxide through the process of photosynthesis. And within the same process, they are producing a lot of oxygen. And additionally, very importantly, as the government of India and the state governments are frantically looking for new skill development ideas, particularly for the urban unemployed youth, rooftop organic farming could be an excellent option, not only for skill development training, but even for converting those unemployed urban youth whose roots are in the rural areas, who have migrated from the rural areas. Those unemployed urban youth could also be converted into organic entrepreneurs inside the city. So it's a win-win for everybody. The city becomes cooler. People living in the city get organic vegetables to eat. And the unemployed urban youth get an opportunity to not only learn something, but to also make money from it. Next slide. Now, when we put numbers to these words, something amazing comes out. So what we have tried to show here is that for a city like Jaipur, where we are headquartered, if 10% of the built-up area of Jaipur could be converted into rooftop farms, these are the amazing things that can happen. You can get almost 300,000 kgs of organic vegetables, which can feed up to 15,000 families. You can get 22,000 square meter of green cover. 15,000 metric tons of carbon dioxide could be sequestered. So these are the various impacts that can happen on a city level. And this is my direct message to the city decision makers, that my request is, please wake up to the fact that urban organic farming or rooftop organic farming is not just about agriculture. It is more about offering a nature-based solution for creating a cooler and livable city. My request to the city decision makers is, don't push urban agriculture into the domain of Department of Agriculture. The Department of Agriculture doesn't recognize it as agriculture because it has got nothing to do with farming. That's why I am emphasizing that urban agriculture, rooftop organic farming should be treated as a nature-based solution for creating greener and livable cities and cooler cities. Next slide, please. Now, luckily, our voice has reached to at least some right places. As ma'am introduced us in the beginning, during the introduction, she mentioned that we are working with the government of Bihar, the Department of Horticulture of Government of Bihar, where 50% financial subsidy is being given to anybody who has got 300 square feet of rooftop area, and he can get 50,000 rupees of equipment by paying only 25,000 rupees. This is an amazing scheme. It has been running very successfully for the past 2 years. And we are proud to tell you that we are the largest registered vendors with the government of Bihar for this rooftop gardening subsidy scheme. Similarly, we are working with the government of Telangana. Now, the government of Telangana is an amazingly proactive government. Even as entrepreneurs, we are supremely impressed with this government. This government, the government of Telangana, has chartered a 100-day program, a 100-day agenda, in which out of the 23 urban local bodies of Telangana, at least 3 urban local bodies would be going for large-scale rooftop farming in their respective cities within 100 days. So this is something amazing that we have seen happening in the government of Telangana. We have also been contacted by the government of Delhi, because somehow Delhi seems to be the worst affected city due to air pollution in the entire country. Despite the fact that there are larger cities like Bombay, but Delhi is very badly affected. Now, the government of Delhi is looking at rooftop farming as a directly impactful method of greening the city and bringing down the heat signature of the city. Then the government of Kerala is also working on a subsidy program for promoting rooftop farming. My previous speaker, Dr. Priya from World Resources Institute, mentioned about it. Then the New Town Kolkata Development Authority has actually made it mandatory to have rooftop gardens. And the most recent and the most amazing development is that the Bombay Municipal Corporation has made it mandatory that any government which has any building which has got plot size of over 2,000 square meter must have terrace gardens. So even the government is waking up to this fact. Next slide, please. So this is what I was talking about, the 100-day plan in which we are working with the WASH Innovation Hub. So the WASH Innovation Hub is actually a joint venture between the Administrative Staff College of India and the government of Telangana to implement on-scale installations for rooftop farming within 100 days in at least 3 urban local bodies in Telangana. Next slide, please. We have had the privilege of working with World Resources Institute India, and in fact, Dr. Priya, who was our first speaker, she is our mentor, our guide for this project. She represents World Resources India in this project, and we are working under her guidance to implement nature-based solutions for making our beautiful pink city of Jaipur greener and cooler. So within nature-based solutions, we are proud to exhibit to you that rooftop farming is now being recognized as a major nature-based solution for making a city greener and cooler. Besides other nature-based solutions like creating urban forest, water body restoration, and even kitchen garden. Next slide, please. So this is what we are talking about related to government of Bihar. Next slide. So what are we offering? What we are offering is called a rooftop farming pack. Our product is called a portable farming system, which contains a completely soilless organic medium. It is extremely lightweight. It is highly porous. And the most important thing is, from a structural engineering point of view, the portable farming system is exerting a uniformly distributed load of only 12 kgs per square feet on the rooftop. The permissible load is, the maximum permissible load is somewhere around 25 kgs per square feet, whereas the portable farming system is exerting less than half of the maximum permissible load. And that is also a uniformly distributed load. And that is because of the fact that we are not using a single molecule of soil in this system for growing organic vegetables. The other important thing is that we are using a completely leak-proof container which is protected from the ultraviolet rays of the sun, and it will stay leak-proof at least for 4 to 5 years. In order to make sure that we are utilizing every drop of water, we are using a drip irrigation system, and in order to make sure that there is no water logging in the portable farming system, we have innovated our own subsurface drainage system. Now the amazing thing is that the portable farming system can give you a 3 times yield as compared to land farming, simply because of the fact that the plants are growing directly into a highly nutrient-rich biofertilizer, and the plant-to-plant and row-to-row distance has been reduced. So the plant density has increased without sacrificing the productivity of the plant. In order to control the pests and diseases organically, we have created an organic input kit where we have organic sprays, organic root fertilizers, and biofertilizers. In order to offer daily online guidance to all our customers across the country and now overseas, we have created an online support system called Plant Doctor Program. And in certain select cities where we are physically available, we are offering on-site maintenance services also. Next slide, please. Now, what we are talking about is converting the rooftop of any building into an organic farm. And that is not restricted to only converting the rooftops of houses into organic farm. Why can't hotels convert their barren, exposed rooftops into an organic farm like this? Next slide, please. Similarly, we are working with factories where the entire rooftop of the factory is being converted into an organic farm. And the most important thing is that because these units are modular, because these units are lightweight, and because these units are portable, there is no problem in taking a decision to put these units, because even if a factory owner wants to do construction after 1 year or 2 years, each of these portable farming systems can be packed and removed from that factory's rooftop. Next slide, please. Now, another thing is, mall owners have had an extremely bad time during the COVID times. Today, most mall owners are looking for new ideas for inviting people to come to their malls. I am talking about a vision where malls, the rooftop of malls would have organic farms, and the freshly harvested organic vegetables would be sold through the retail outlets that will exist in those malls. Now, just imagine if the mall is able to advertise that I have an organic farm on my rooftop and you can get freshly harvested organic vegetables from my rooftop. Imagine the increase in footfall that the mall owner can see. Next slide, please. Not only malls and hotels, we are even talking about offices. There are many corporate offices which have got very large buildings and absolutely nothing is happening on their rooftop. So besides producing organic vegetables, the rooftop farming project can also offer a stress busting activity for the employees of that office, which means, in simple language, during lunchtime, people can actually come on the rooftop, forget about their commercial and official problems, get down to doing some gardening and undergo it as a stress busting activity. So corporate office can do rooftop farming and offer two things to their corporate employees. One is fresh organic vegetables, which is a big thing for the corporate employees. And secondly, a stress busting activity opportunity. Next slide, please. And sure enough, anybody, any homeowner who feels that he or she would like to grow their fresh organic vegetable, they can convert their rooftop into an organic farm. And here I would like to emphasize that we are different from a plant nursery or a gardening store because we complete the picture. We are offering a product, we are offering pest control and disease control kit, and we are also offering online daily support. Next slide, please. So even hospitals, once again, look at the hospitals. They are huge buildings, nothing is happening on the rooftop. Even hospitals can become can do rooftop farming on their exposed rooftops. Next slide, please. Now, this is something which is this dream is very dear to my heart. I want to teach farming to the children. And every school may not have the land space or the ground space to have a farm. But I'm sure most schools, even municipal schools, even government schools, like I said, we have had the good fortune and the privilege of working with the World Resources Institute, not only in Jaipur, but in Bombay also, where along with the World Resources Institute, we are working with Bombay municipal corporations to create a school farming program and to create 2 large rooftop farms on the rooftops of 2 municipal schools that are being run by Bombay Municipal Corporation. And this is being done as a pilot. If the pilot is successful, the Bombay Municipal Corporation has got over 1,000 municipal schools. Imagine every school becoming a every school having a rooftop farm on its terrace. Next slide, please. And as I said, we can train the urban youth. Today, the urban youth have to migrate from their rural areas. They come to the city and they have to learn all sorts of new skills which are not naturally easy for them. They have to learn accounting, they have to learn different kind of skills. But imagine you are teaching an other urban unemployed youth who has migrated from the rural areas, you are teaching him organic farming, and he can do two things. One, he can offer on-site maintenance services to all those buildings who are doing rooftop farming on their rooftops. Number one. Number two, the same trained urban youth can also take a large, with the help of the government, with the help of the municipal corporation, with the help of any CSR fund, that trained urban youth can be given a large rooftop along with a rooftop farm, and that urban youth will himself grow the vegetables and go and sell it to HNI clients and to premium restaurants which are located inside the city, and he does not have to invest in any supply chain. We are talking about a carbon neutral supply chain where vegetables are being grown on the rooftop and they are being transported on a bicycle to the house of an HNI client or to a premium restaurant. Next slide, please. Now, I don't want to confuse you with these numbers. All that I want to tell you is that besides environmental reasons, which may not directly impact your decision making, if you're a hotel, if you're a hospital, if you're a school, if you're a mall, you might say, well, it's good to do something good for the environment, but ultimately, commercially, economically, does it make sense to grow vegetables on the rooftop? My simple answer is that when you can get organic vegetables for 23 rupees a kg on your rooftop, why would you like to go and buy it from a shop? So rooftop farming is an economically viable proposition for any building owner. We can also, next slide please. We would also like to bring a bit of technology in this picture by creating an app which we call a City Fresh app. We are working with the government of Telangana for this app, where anybody, any urban citizen can find out where is the nearest rooftop farm from my house, what is growing in that rooftop farm, when is it going to get harvested, what is the rate at which I can go and buy it, can I place a doorstep delivery order for my vegetables to a rooftop farm. Imagine everything happening on the mobile, you sitting at home, placing an order to a rooftop organic farm and getting freshly harvested organic vegetables delivered at your doorstep. Next slide, please. Next slide. Okay, let's move on to the next slide, please. So besides growing organic vegetables, we have a product called a fruit growing bag in which we have been successfully growing organic fruits on the rooftop. Next slide, please. And for those people who are living in flats, in apartments, but they do have balcony space, we have created a vertical vegetable growing system which enables a flat owner to grow edible herbs vertically in his balcony. Next slide, please. Dr. Pofli talked about green walls. We have been creating green walls for the past 10 years. We have created green walls for smart cities. We have created green walls for large corporations. And I'm very, very interested in exploring a tie-up with CSIR specifically for that technology of filtration of water using green walls. So I'll be very interested in reaching out once again to CSIR Niri for that. Next slide, please. So these are some of the green walls. Next slide. Next slide. Next. Next. Okay, now one very interesting idea that I want to share with the August audience, and that is called a living billboard. So we haven't created this; we have very clearly written it. This is a reference picture from the Google, but this living billboard is actually physically installed at one of the underground tube stations in London. Now, why we are talking about this is because Till now, most municipal corporations have been thinking of creating green walls around metro pillars. They've been thinking of creating green walls at railway stations and bus stations. We want to take that one level up. Instead of creating green walls, which may not be able to generate any advertising revenue for the municipal corporation, we would like to promote the idea of living billboard, where two things are happening at the same time. A living billboard is purifying the polluted air in a high traffic area because it has got plants, but at the same time, it can carry an advertising message of a company or a business owner. So I would like to propose this idea as a revenue generating idea for all municipal corporations and even
We have
for
2 minutes to
institutions
just
like Indian Railways. Next slide, please. Next slide. So this is also living billboard. Next slide. Again, an example of living billboard. Next slide. Next. Little bit about our clients and partners. Like I said, we are privileged to work to work with World Resources Institute. We are working with Administrative Staff College of India. We work for Smart City Udaipur, Smart City Kota. We are working with Bihar Horticulture Society. So these are our clients and partners. Next slide, please. Next. Next. So thank you very much for being patient listeners, and I'll be happy to answer any questions at the end of this event. Thank you very much.
Thank you, Pratik ji. I think that was a very, very detailed understanding on what rooftop can do for the city urban areas and also the residents, inculcating nature connectedness to food security, to livelihood, to reduce heat stress, improve micro environment. So there are a lot of things, and especially inculcating these values and benefits in the next generation. So developing a kind of intergenerational partnership is something that is, I think, very relevant from your presentation that I can take up as a major output. I will now move to the next session and next presenter of this session because we are a little ahead of the time allocated, and I don't want to be in between this interesting presentation. And I'm thankful to Dr. Ashish Kumar Yadav, who is joining us from Spain. Welcome, sir, and apologies if we kept you waiting for a little longer time. Dr. Ashish Kumar Yadav holds a permanent position of Principal Scientist at CSIR Institute of Mineral and Materials Technology, Bhubaneswar, India. Currently, he is working as a Marie Curie Fellow at Rey Juan Carlos, Madrid, Spain. And he is the pioneer of constructed wetlands coupled microbial fuel cell technology for energy production. So this is something relevant that he will be sharing with us. Also wastewater treatment and other environmental applications. He has numerous awards to his credit that includes not only Marie Curie Fellowship in Spain, but also Indo-American Research Professorship at American Society of Microbiology. He is 4 times winner of Erasmus Mundus Scholar Awards for teaching and research in universities in Germany, Poland, Sweden, Portugal. He's also winner of BLIR Scholarship of Belgium and Nuffice Fellowship of the Netherlands. He is an adjunct faculty position at the University of Tasmania, Australia, and his larger interest lies in developing low-cost energy generating and saving wastewater treatment systems that have the capabilities of resource recovery. Besides, he's also interested in developing circularity and sustainability in water and wastewater treatment systems. I'm really happy to invite him because I think he will be providing more insights on, especially when we talk about Atmanirbhar Bharat. Swachh Bharat is one of the important campaigns running. So his thoughts on constructed wetland and coupled technologies for enhanced environmental application is something, a very important nature-based solution that can improve our understanding and also understanding of corporates and urban planners to take up these technologies for further implementation. Over to you, sir. Do you want me to share?
Uh, mm, thank you. I'm going to share it from
Okay.
my end because I don't think like you have my slides.
Okay, sir. Please go ahead.
Yeah. So, oops. I think second. No. I think there is a problem. Second.
Is there any issue with
No. Just like give me a second. I guess like it will be solved because we have already tested. So I don't think like it will have some issue. No window. Oops. Right, it's not showing. 1 second. Why it is not happening? Oops. Yeah, I guess like now it will happen. Ah, are you able to see it?
Yes, sir.
Okay, so thank you so much, Dr. Dhyani, and thank you so much to the organizer for giving me opportunity to talk on uh, nature-based solution. And you all know that constructed wetland is considered as one of the nature-based solution. And up to now, like constructed wetland in India, they are like in their early stage, so people are making a lot of opinion about them. And uh, another issue is like still we are in India, we were not able to use this wonderful nature based solution technology, particularly constructed wetland. And so here like I'm going to talk about constructed wetland and its use in different type of or its coupling with different type of technology for enhanced environmental application. So I'm not limited up to only wastewater treatment but on many other issues. Okay, so is it moving?
Yes, sir.
Okay, so those who are working on wastewater treatment, I wish to tell, or those who are involved in nature-based solution, particularly on biological things, then they should, and those who are involved in doing research or implementing nature-based solution for wastewater. Uh, then they should understand there are two type of uh, I'm just like going little bit in scientific basis on this. So uh, there are two type of biological reactions involved in nature based solution, and these are aerobic reactions and anaerobic reactions. And aerobic reactions based nature based solution is fast. So in aerobic system, you need to supply air from atmosphere, particularly oxygen, but the air is good source of oxygen. So you have to inject air in your system, and that in air part, like oxygen part, will work as a electron acceptors, and you will do some biological reactions for particularly for wastewater treatment or any other applications. Okay, so aerobic systems are little fast, and if your system is fast, then you can make very compact or um less footprint generating systems. Okay, uh, but another way is anaerobic treatment systems, where you are not supplying any air from outside, and since you are not supplying air from outside, then you are saving lot of money, because like you are not running any pump or anything. So here in anaerobic system, the reaction is happening based on one electron acceptor, that is you can say like nitrate sulfate, but they are in limited number. And anaerobic system is like is not like energy intensive system, but they are very slow. And that is why if you are relying on slow system, then the land footprint will be very high, and that is not very good situation for our cities where land cost is very high. Okay, so with this small scientific background, like here I'm just the take home message is like electron acceptors and then kinetics. That one system, if system is fast, then you have to invest extra energy, and it means that you have to invest the cost. And if you are relying on not means like slower system, then you are saving the cost, but you are increasing the footprint. So it is like very complex situation. Okay, so now I'm coming to our constructed wetland. So how constructed wetland look like in field, a well managed constructed wetland. So here are the pictures, and these constructed wetlands were implemented by our research groups in different locations. One of the constructed wetland is situated and working in the Central Police Force Colony in Bhubaneswar, and it is treating some like 100 KLD of wastewater every day. Another two systems are working in our institute premises in Bhubaneswar, and here like you can see the treated and untreated water. Okay, so untreated water is not very clear or not very good looking, and then nobody will use it. But a treated water is relatively clear. And then if you see the performance, so it is performance like the cumulative performance of many years. So we find that we can remove 60 to 80% of total solids, and similarly COD up to 94%. Phosphate removal is like a little low, like 52%, and similarly about nitrogen removal, which is like somewhere 6 to 81%, ammonium removal 67%, or nitrate removal 81%, and pathogen is nearly 99%. So these are the typical performance of constructed wetland if they are designed in scientific manner. Okay, and if somebody wish to know more about constructed wetlands, so these are the simple basin filled with river sand or gravels. And on this river sand or gravels, with time, like lot of microbial biofilm is deposited, and we are also using plants in this system. So in general, if you have to, in simple way, if somebody wish to know about constructed wetland, then they are the basin where your plant, microorganism, and physical environment like sunlight, soil, or air interact and improve your water quality. And these are very simple system, but we should design very nicely. Okay. So why I'm like more towards constructive wetlands? So there are a lot of benefits, particularly in developing country like India, uh, if we use constructive wetland, because they are very low cost construction, operation, and management cost, and they don't constructive wetland does not require very skilled manpower. So just like with some training, you can like hire a person with some basic qualifications, and they can easily operate constructed wetland. Why they are important? So if we consider electricity, so constructive wetland is completely passive treatment technology, but it means that they are not running any process which need any electricity. So without any electricity, you can run your constructed wetland for wastewater treatment applications. You don't require any chemical, so there is no need of addition of any chemical if you are employing constructed wetland for treating your wastewater. There is no sludge generation, and even there not any machineries is required to run your constructed wetland. So they are completely nature based systems. Low cost constructions, and low with you can make your constructed wetland with locally available material. And then the operation and maintenance cost is also low. And you have seen the pictures, and you can see that they are looking like a garden. They are noise free systems, so you can use them in any kind of setting. Another advantage of constructed wetland is, like, you can use your constructed wetland for variable flow. So for one family, whatever wastewater is generated in a family, you can use constructed wetland to treat that wastewater. Or you can use a constructed wetland for a community. Okay, that kind of feasibility is not there with other type of wastewater treatment technologies. So this is also very important. So these are the some of the good points, and which make constructed wetland fit for Indian conditions. Okay, so now I'm coming to the next point: why constructed wetland is not becoming popular in India. Because constructed wetland are anaerobic treatment systems. Okay, and in my first or second slide, I told, like, anaerobic systems are not not requiring any external energy source, but they are slow. And if any treatment system is slow, then you need, if you wish to implement them, those kind of system, then you need larger land area to subsidize the slowness of the treatment technology. And same thing is happening with constructed wetland. Suppose a realistic scenario: if if I will give presentation to some of the end user about constructed wetland, they will be attracted towards implementing this kind of this treatment technology. But when they have to implement, or if we go with them, and then if they will show the we will show that, okay, I need 1000 square feet of land area, and that guy is having, or the company is having very short place, or like not having that chunk of land, then they will not implement. And exactly this is happening. Constructed wetland need larger land area. So they are fit for Australia, where large land area is available and population is very low. They are fit for other countries, but not they are not becoming very popular in India because of their slowness. Okay, and they are biological systems, so they cannot treat all kind of pollutants at like required standards. So in such situation, uh, we have to do some research on constructive wetland, how we should enhance their treatment capacity. And that is why, like, in my opening slide, or the topic is constructive wetland coupled technology for enhanced environmental applications. Okay, so constructive wetland, people are knowing about constructive wetland, but the real there are several issues in implementing constructive wetland. So we thought, like, as a researcher, we started, like, how to improve the constructive wetlands treatment performance, and other how to solve the other shortcomings. So there is a need of new type of constructed wetland in India, particularly for implementing in India, because These are very good technology and we should not ignore it. So there is a need to do more research on this. They so there is a definitely there is a need. So in this context we started working like almost 10 year back. We started working on this direction, and when we were doing some of the experiments, we find there is another technology which is like people, lot of researchers are testing it in laboratory level. They are like 100 ml or 200 ml, and our wastewater is always like in millions liters or like thousands liter scales. So I will talk about little bit from lab. And there is a one is technology that is known as microbial fuel cell, and it is like in all over world, like people, a lot of people are working on this technology because it can generate little bit electricity through biological mean during wastewater treatment. And they use they are in this but they are like always like microbial fuel cell is like lab level technology which is only working on the lab benches or uh, something like this. And it is not implemented any time for any practical application, but still people are interested because it has a lot of exciting things like electricity generation during wastewater treatment. Okay, so in this technology, one part is anaerobic, where anaerobic reactions are happening, and other part is aerobic, where aerobic reactions is happening. And in my first or second slide, I talk about electron acceptor. So in anaerobic treatment systems, like you use nitrate or sulfate type of electron acceptors, and by that electron acceptor, you do the oxidation of the pollutant. But I have noticed noticed this in this microbial fuel cell treatment technology. The conductive material is working as a electron acceptors, and even conductive material is working as a electron donor in aerobic part. Okay, so I don't want to confuse the audience here. I just wish to say that in this treatment technology, the conductive material, conductive, whenever I am talking, telling about conductive, it means that which can which can take electron and it can transfer electrons, like our graphite or our small batteries, or like our electrical wire. It is conductive. This means like our electricity is passing. Electricity is nothing but electron. So here also, and even biological reactions is also like redox reaction, where exchange of electron is not biological. Every chemical reaction is having that thing, like you are exchanging electrons. Okay, or like transferring electron from one molecule to another molecule, and you are doing your work. So same thing is happening in our biological wastewater treatment or wastewater treatment, uh, but not with conductive material, with not with the assistance of conductive material, but in microbial fuel cell it is assisted by conductive material. Okay, so take home message is like conductive material can work as a electron acceptors or donor. Okay, so this is, suppose like this is your microbial fuel cell where anaerobic part is there, aerobic part is there, and suppose this is your constructive wetland. In constructive wetland, large portion is anaerobic, and that is why they are slow and they need larger land area. And in upper portion where your constructed wetland is exposed to the atmosphere, where in that zone you develop some aerobic part. Okay, so larger portion is anaerobic, smaller portion is anaerobic. And in microbial fuel cell also same similar situation is there. So we thought, why not we should merge it, and we merged these two technology, and that's why I say like it is coupling of two things. Okay, so now we are like providing conductive material as a electron acceptors or donor, and we made new type of constructed wetland where we are using electroactive materials or conductive materials. And with this, like now, sorry. Okay, so now this is the new type of constructed wetland, and which is having like more capacity to treat your wastewater at faster rate in compact mode. So this kind of coupling is very useful, and CSR IMMT Bhubaneswar is having 10 year of experience of on this development, and we are really like interested to transfer this in field, and we have several patents on this direction on new generation constructed wetland, which are fast, which will be more compact. Okay, now moving to another use of constructive wetland. So we recently are like from last 3-4 years we have tested new model of um, public toilet. I'm deliberately telling this is more suitable for public toilet. So in public toilets, even if you have you are building public toilets, and if they are not very clean, then people are not using. So this is like we can experience this situation like at every railway station or like a bus stop. There are public toilet, but people are not going inside the toilet, but because like they are not very clean, and people are using the outer spaces for urinations and other things. So we realized that okay, there is like in India public toilets are there or limited in number, but even if you are establishing the public toilet, if they are not if they are not clean, then nobody will use. So with this thought, we thought like okay, why not we should use more water to clean our toilets, public toilets. Okay, and from where this water will come, then we thought like why not we should treat our the used water, or like the water which is used in the toilets. Okay, so with this observation we started working on this, and we come up with new type of model of public toilets. And in this public toilets, we like these are like deliberately we are not telling zero discharge. Zero discharge means like nothing is going out, but we are telling minimum discharge. Okay, because we are losing some of the water. So in this public toilet, we improve our septic tank. Then after septic tank, the water will go to our constructed wetland. This is also like innovative constructed wetland where in very compact space we can treat our the post septic tank water. And in another step, we are using electrochemical systems, which is also passive, you can say nature based, because we are not adding anything, and another slows and filters type of things. So altogether, our water, whatever water we are using in our toilet for cleaning, that is getting treated through nature based solution, and treated water is again moving back to the toilet, and it is moving back to the toilet in a separate tank which is having uh, which is completely closed. You even no user can touch that water. Okay, because that is like only coming to the flush tank, and flush tank is having bigger size. So in place of cleaning our public toilet with 5 liter or 10 liter of water after every use, in this system we are using 30 or 40 liters, because we are not losing any water. We are losing just like cleaning our toilet with large amount of water, and that water is like going to the septic tanks, and once again it will move towards the our treatment technology and stored. And all the process is semi automated, means like whenever the tank will be vacant position, then the sensor will work, and then the tank will be filled. So every time, like, it will be fully automated and without any touch. The treatment quality is very high. Even then, we are not recommending to touch it, and even there is no need of touching. So here, this nature based solution, we are using it for in public toilet, and then this is like ready, and then this toilet model is working in our campus. We have taken the patent, design patent on this aspect, and this is like a very good, and I'm like really impressed with this simple solution for using in toilets. Okay. Then our same constructed wetland cum microbial fuel cell, we have tested it for many other purpose, like for textile wastewater, and we were able to treat our textile, decolorized our textile wastewater, and even mineralize the metabolites which are toxic. So we were completely able to mineralize our pollutant, the toxic pollutant, to non-toxic pollutant. That is like big achievement, and we have taken patent on this. So this is also one of the nature-based solution. Okay, so thank you. I have just like included few example. There are many others things we are doing on this aspect. Thank you.
Thank you, sir. I think this is a very important presentation because constructed wetlands are very much here and implemented and talked across the country at various forums and platforms. One thing was there that right from when we started discussing about this event, one important question that you answered through your presentation was, do we have enough land to actually implement constructed wetlands in the country? Because if you see the kind of expansions we have in urban areas, we don't have enough open land actually to have this system. So thank you for sharing this next generation, next level constructed wetland technology, and also sharing this important insight on self-sustainable, zero discharge, hygienic toilets. Because while we have a lot of urban expansions, we also have a lot of tourist destination coming up in the country. At the same time, most of the issues are related to hygiene and sanitation. So that's something where this can be taken up, where with little quantity of water, uh, the toilets can be more functional and efficient, especially if you see the industrial setups in mining areas where there is already water shortage. You see the other industrial expansion where these kind of settings will be very relevant. And at the same time, they use nature-based technologies, the power of microbes, the power of plants to actually clean, and the root zone constitution of these microbes and how they purify this entire system. So I think this very much is in context with this entire discussion and takes us to the next level of how we can improve these systems. And so thank you for sharing these insights. And I'm sure the technology that you are sharing is also cost effective, that can be taken up because we need a lot of private sector financing in these nature-based solutions. Thank you so much for sparing your time and sitting. I don't know time zone that you have, is this able or not, but thank you so much for joining in. Without wasting much time, because we are already half an hour ahead of this schedule, I'll not miss on taking up the next speaker, who is Dr. Ninad Raut. As you know, air pollution is another important issue for urban areas. Not only urban areas, but if you see industrial developments, be it thermal power or mining or any other industry, especially all these dirty industries where uh, either these overburdened dumps are having these the soil and fly ash blowing in the environment. So this all leads to a lot of particulate matter and also a lot of vehicular emission in urban areas that lead to not very clean environment to live in, that affects human well-being also. So on that line, We have invited our next speaker for this event. We have Dr. Ninad Raut with us, who is heading the Ecology and Biodiversity Department of Terracan Ecotech Private Limited. It's an ecology-based environmental consultancy firm based in Mumbai. He has been instrumental in planning and designing all projects related to ecology, biodiversity, and NRM. He is handling business development, project execution, team management, and capacity building. Under his leadership, the team has executed a lot of NBS projects, and that also includes biodiversity action and management plan development, doing tree inventories, green belt assessment, valuation of ecosystem services, auditing of biodiversity, sustainability, CSR funding, carbon credit, and so on and so forth. He will be presenting and giving us insights about the technology that is developed by Terracon, and that's Green Tunnel. Again, a nature-based solution to reduce urban air pollution to improve natural infrastructure. So over to you, Ninad. Do you want?
Dr. Dani.
I would request you to present from your end if it is possible.
Yeah, sure. So very good afternoon. In fact, good evening to everyone. So we are behind the schedule. Let me present the presentation. I hope the presentation is visible.
Perfect.
Okay, thank you. So NBS, I guess a lot has been talked about NBS since the beginning of this session. It's very important, critical to address the climate change issues, and you know, from the first speaker or the introductory video, we saw that how difficult it is actually, although we are creating impact on the nature while developing a lot of stuff, it's very difficult to integrate the biodiversity into the development. And that's more when we are looking at the cities, because when 2% of Earth's surface is occupied by cities, but almost 50% population is currently residing in it, and we are expecting that this number will increase to 90% by 2100 year. So this rapid urbanization versus critical natural capital reserves that we are looking forward for a well-being of a human mankind and our health especially. What are the things that are getting impacted due to the developmental activities? So one thing which is more talked about is the urban heat islands and flash floods, or the microclimate level changes that is appearing. So if we just take an example of a city like a Mumbai, which is a metropolitan city, in last 30 years, we have lost almost 42% of green cover due to various activities. And majority of the times when we say development, the road becomes a road connectivity, or the construction of road becomes a one of the primemost factor that creates or that fragments the habitat, or that creates a declining of the green cover. But that also has another impact of air pollution as well as the land surface temperature. So when we are looking at greening the cities or urban local the urban biodiversity, what are these important for? So probably we have talked about the biodiversity or the greening to the extent possible. However, the ecosystem services that the biodiversity is providing, in addition to many other parameters, they are enormous. It can create an not only the green cities, but it will also help in mitigating all types of pollution levels. Also, as indicated, that urban heat islands effect, but also maintaining a ecological balance in the cities. It is already proved by many research that under the tree canopy, the temperature reduction is has a good result. So we thought that why not this particular green tunnel? Now, what is the difference? So this green tunnel is nothing but a kind of a pergola like a structure, but it's built upon the frames of a bamboo and using a climbers. Now one will ask the question that why? I mean, there are trees, but in cities, as mentioned by the moderator as well as the speakers, that space is a constraint in the cities. Now when space is a constraint, I guess probably we are losing on the tree cover or the already existing trees for further development, and the roads are connecting to each other through the narrowly available space, and then we are again very in a situation where we will not be able to plant more trees along the roads in the cities. So although we are talking a lot about plantation and trees to be planted around along the roads, the space constraint is going to impact our motive or the objective of making the roads green. Now to resolve that issue, we have come up with this solution where the bamboos can be used for the initial I mean this green tunnel using a bamboo structure can be used for the initial development of the canopy, as well as wherever there is a space constraint, this can be utilized over the roads to reduce the land surface temperature as well as to improve the air quality. This will also enhance the local biodiversity. Now, if you see that in the cities, although we talked about greening it, many a times the manicured landscape brings the exotic species within the cities. Now that is also having impact on the local biodiversity, and that is why we are proposing that the native species of climbers will be used or should be used when we are promoting the this green tunnel. So this structure will be a sort of a dimensions that we have thought about is a central height of a dome should be at least 18 feet height, so that the big vehicles can also move beneath. The length of a bamboo should be at least of a 16 feet. So a if there are trees, it could be in between trees will be placed, and a kind of a 1 meter spacing will be given from the trees so that the canopy will not be clashing to each other. And the width of a 1 meter on each side will be considered. So the kind of a resource material that is required for this is essentially we'll have to develop a nursery, because we are talking about native climbers, as well as to increase the nature verges along the roads or along the medians, the shrubs and herb species which are capable of to take the roadside loads of pollution dust can be will have to be raised. uh, uh, this nursery will be kind of developed in such a way that the saplings will be available at a local level. And for green tunnel structure majority, because this is going to tackle the entire structure or hold the entire structure, the bamboo poles as well as the bamboo mats will be used. There will be climbers which will be planted along the poles. Coir ropes will be used to tied up the structure, and some kind of a checkered pattern of a roof portion will be used to ensure that the street lighting will also trickle in between, so that it won't be a dark and then we are again moving on the lightning of the road. It will require seasonal maintenance. Solar pump will be used to irrigate the climbers, and obviously we'll have to introduce a drip irrigation so that the it will be maintained in that way. We are also proposing to use the instruments to understand the difference between the experimental areas as well as the control areas. The implementation skeleton is very clear that the roads with less canopy cover and high surface temperature will be targeted to implement this, and this requires a kind of a 2 months construction time for around 500 meters unit area, plus seasonal maintenance, annual maintenance, which will be required. But what we are proposing here is the urban local bodies could be the stakeholders. So we are trying to bring all the stakeholders into it, where the permissions will be required, and for electricity, water, protection, etc. This implementing the project implementation agencies like Terracon will manage, construct, and monitor the entire structure during the its implementation as well as operational duration. But local agencies, local nurseries, or the local community can also be involved in bamboo cultivation, or these will be engaged in procurement of a bamboo poles as well as the climbers and shrubs and hubs that will be required. This will also help in the disseminating knowledge, awareness, because this can be definitely used for promotion of the ideation, as well as the this particular green tunnel may not necessarily be only, although we are looking at cities at a major stake, but industries can also be targeted to implement this structure within their campus along the road. So if it is an industry, their employees can be part of awareness program, as well as when it is in the cities, the university students or the school students can be part of this particular program. Now, we have also identified some risk related to this when we are constructing it. Let me tell you very frankly that this is a conceptual ideation that we have proposed. We are yet to implement this. We are looking for industrial as well as the institutional partnership to take along to take these activities further for the funding as well as implementing areas. But this is a kind of a required stuff, because when we are talking about space constraint and we are going ahead with the various NBS to tackle the climate change issues, I guess roads are something where we see the devoid of the canopies, although some roads which have the avenue plantation, but they are not merging to end in the width. So this particular situation, in this particular situation, we need this kind of structures to hold. But when we are proposing these structures on a road withstanding the natural forces, wind velocities, etc., needs to be identified or discussed. Human disturbances, in especially in countries like India, where we have lots of this kind of menaces, mildew and fungi growth on the bamboos, because this will be a bamboo poles and not the live one. So this could increase the maintenance activities, and light penetration after climbers growing on the bamboo mesh will be and another risk. Have an advantages on the on its alternatives, like when we are saying avenue plantation, but space is the constraint. Nowadays, people are moving to electric vehicles, but the emission will be low, but land surface temperature will not be reduced. We are in building, we can switch on the ACs, but again, I guess one of the speaker rightly mentioned that above 50 degrees ACs are also not working. But again, we are contributing into the carbon footprinting. So same with AC vehicles, when we are moving ahead in the high temperature areas, we can switch on the ACs, but that will also increase the carbon footprinting by us. And one may say that bamboo being a material that can increase the maintenance and use the metal, but then we are losing on carbon emission or carbon sequestration done by the native plants or the bamboos, as well as most of the
2 minutes to finish.
yeah, sure. Losing many ecological benefits. So this is kind of a business model that we are proposing, where Terracon being a project designer and implementer, and this particular model we are thinking that the urban local bodies and corporates as well as industries should take up. And I mean, this has a project proportion or projections to implement around if entire India gets into it, or the urban local bodies of India. I guess we have a around 10,000 square kilometer road network that can be converted, and that will be a huge amount of reduction into the temperature, contributing to our commitments to the international conventions. So to summarize, that this green tunnel and solutions which we are targeting to act as a nature-based solution to address the climate change related issues like pollution reduction, air pollution reduction, and land surface temperature. And we being a consulting agency now getting into the execution or implementation role since last 10 years, working into the domain of ecology and biodiversity, providing solutions to our clienteles. We kind of looking forward to implement this in a bigger platform and in various cities. I guess if due to time constraint, I have to cut short many things that I wanted to talk, and people are and the audience are really welcome to contact us for any further discussions on it. Thank you.
Thank you, Ninnath. I think that's important what you are targeting through Terracon, though in the conceptual stage, I think some of the relevant suggestions as part of CSR can be looking to the plants that are more native and at the same time have excellent air pollution tolerance, and at the same time are also having some good root system to improve groundwater percolation, and have the broad lead system that can help improve noise attenuation also can be, because CSR NERI has implemented a national green highway in close to Nagpur. That's about 7 kilometers of 7 years of work that has been implemented. So I'm sure that can be a good idea to have that approach in mind, and you may like to refer to that approach. But I'm sure your approach itself is good for urban areas and can be a good take up area or a concept for not only corporates but also urban planners. Thank you so much to be part of this discussion. And because I know we are already ahead of almost 1 hour from the schedule that we were given, so I think though I have questions, I should not take questions because there are a lot of senior experts in this panel who have other commitments and who want to leave this session. One of them has already left after telling that she has some other meeting to go. So I think what I could see in this discussion that started from understanding the mess of urban areas in the country and the context, and then we find a lot of good solutions also. We see how gray water can be treated and used for vertical walls. So that's a good area. And I also see a lot of interlinkages with different technologies. If they can be mixed together, can be a very good sustainable solution for urban areas. Then Manish sir's approach of geopolymer based, fly ash based concrete that is reducing less carbon and also is tolerant to heat stresses. So that coupled with other technologies can be a good solution. And then, of course, Ashish sir talked about next generation constructed wetlands and coupled technologies. So that's another addition to improve the urban settings and urban areas and improve the human well-being in the larger context of climate change and the scenario that we have right now. So before I end this session, let me please share my sense of gratitude, first of all, to Dr. Gopal Iyengar, who is Theme Nodal for Climate Change from Ministry of Earth Sciences. I also thank CSR Nodal Dr. Mahendra P. Darokar, who is one of the organizers. And then one of the most important person, Director CSR NERI, Dr. Atul Vaidya, who has been great support and a force behind all these important events that we are running. I should not forget to thank Dr. Sadhna Railu, who is also senior most scientist of CSR NERI. I would also thank Dr. Girish Pofli for his suggestions regarding important areas that I should look through in this session, and also linking us to some great speakers and people and scientists who are developing some great technologies for the country. I also thank technical support from CSI team, including Ms. Palak Dikshit and others who were involved throughout for last almost 2 weeks from now. Last but not the least, all the speakers, right from Pipriya to Dr. Girish Pofli, Dr. Manish Mudgal, Dr. Ashish Yadav, then Mr. Pratik Tiwari and Dr. Ninad Rao. Thank you so much for sparing our time and staying a little more than what was expected from you. So thank you so much. And we hope that whatever outcomes of this session will be, because we are asked to share some of the insights and how we are going to take this session ahead and what kind of industrial interests are from this session, what kind of technologies they are interested in. So I'm sure there might be something more that I will be coming back in forthcoming weeks. With this, I would like to end this session. And once again, thank you, everyone. Thank you and goodbye.